Hello everybody, my name is Dzepina and welcome to my first podcast for the Diamond Science and Technology CDT. The topic of today's podcast is based on a talk given by Professor Richard Dashwood at the University of Warwick titled Lightweighting Challenges for Low Carbon Mobility. Due to the enormous impact of human activities on the environment, in 2009, the European Commission set stringent and binding targets to reduce CO2 emissions of new cars. Failure to meet such targets would result in vehicle manufacturers being penalized £75 for every gram of CO2 per kilometer over the target. As it currently stands, new technology is needed to fulfill these requirements. The two main avenues for research in this area are propulsion and the focus of this talk, lightweighting. The first question we may want to ask ourselves is what material is best to use. There are a number of factors to decide which material is right for the job. These are the Young's modulus, or stiffness of the material, tensile strength, density, price, and availability. Contrary to our first intuition, you don't have to use low-density materials. There is a reason that over 99.9% of cars on the road today, including the Toyota Prius, are made from steel. It is a very strong and stiff material, which allows us to use thinner gauge. Advances in coating technology prevent the material from rusting, and because the steel industry is so well developed, it is extremely cheap. Another important metric to look at is the life cycle contribution, or the carbon cost for producing the material, where steel still trumps its competitors. That said, what are the alternative materials being looked at? What about aluminium, which is mostly used in high-end cars? By replacing steel in the body, more than 400 kilograms was shaved off the new Range Rover. And on the other side of the pond, aluminum allowed the Ford F-150 to lose 300 kilograms. Unlike steel, in which sheets of metal are stamped, aluminium has a variety of forming techniques. The other good news is that if you recycle aluminium, the energy cost is only 5% that of virgin material production. Coupling this to the issues with the supply chain mean that 75% of all aluminium remains in use today. Magnesium is another option which can be widely used to replace steel in many components. Magnesium is typically produced in one of two ways. There is the electrolytic route and the metallothermic route. Unfortunately for the planet, most of the world's magnesium is produced via the cheaper and dirtier metallothermic process, thus making the material less attractive. Titanium is a fantastic material. It is strong, light, and fairly chemically inert. This makes it ideal for use in hot and corrosive environments such as exhausts or springs. Sadly though, the cost of producing this material limits its practicality in the automotive industry, and thus it is only used in cars that can be afforded by football players and rap stars. Carbon fiber is the lightest material of the lot, and relative to its weight, it's also the strongest. Under impact, carbon fiber can absorb a large amount of energy, thus making it remarkably safe to use as a passenger cell. Similar to titanium, not only is it extremely difficult and expensive to make, but its production is also energy intensive. Also, we currently don't have a process to recycle carbon fiber. So where have we actually landed with all of this? We know in the current paradigm that steel is king. The other materials such as aluminium, magnesium, titanium and carbon fiber are simply too expensive in terms of production costs and energy input. However, a great deal of fundamental research is currently underway to address these issues, and it's only a matter of time before these materials become viable alternatives to steel and change the course of automotive history forever.